all of us are working in cloud computing because the expectation is that we will be able to provide a solution that are able to scale effectively and also in a cost-effective way. But however, if you consider the cloud system, the current cloud system from the performance point of view, there are some problems. So, for example, the performance of the cloud system varies at the time of the day according to the resource contention of the application that share the physical resources with our application actually. Then there are some problems related to the fact that the ramp up of the resources sometimes there are no quality of service or guarantees on this also. And if one needs to consider to move an application to the cloud, actually there are several quality of service metrics that he needs to study, and these quality of service metrics can be in conflict and usually in conflict with the cost. So what we are doing actually is to build some methodologies, some tools that allow us to estimate the quality of service and the cost of a cloud application in design time. So my talk will focus on the work that we are doing design time. And even from a cost perspective, my talk will be focused on the cost of use of the resources, while other parts in clouds are considering the broader cost model, and this is only one part of this. But even if you just consider the cost of usage of the resources, there are several pricing models, several cost metrics, and so even evaluating the cost of a cloud application is a challenge on a case. So the goal again is to build these design time tools, and the talk here I will focus on the performance assessment, the cost assessment of a solution, while in MODACloud project our goal is also to develop an optimization tool that allows us to determine the solution that minimizes the cost while guaranteeing quality of service SLA. So this is the original. Before I will show you some evidence of the problems with some experiment that we did with the cloud system. So actually here I have considered the SpecWeb benchmark, which was used as a reference to evaluate the performance of web servers. And actually, this is what we are obtaining by using a state-of-the-art solution, the Palladio Bench, which is also our starting point in MODAClouds, with some real data that we gather. So the line is what we got from the Palladio tool, where the dots are the value of the response time of some web pages. This was for the login page. By running some experiment on the SpecWeb tool in Amazon SH2. So what happened is the following. If you consider these are the response time versus the number of users, and if you see here, if the loading slide, so these data were gathered for 10 or 100 users, let's say, you see that what you get with the standard state-of-the-art tool is very close to the response time that you can measure in the real system. While, and if you look at the individual web page response time, you see that these spikes are normal. This should be due by the garbage collection activity, for example. So there are not too much variability in the response time, and what you can get with the models fits the real data. Well, this is what happened when we move to heavy loads. Actually, in heavy loads, you can see here that there is a huge discrepancy between what you get from an analytical model and the real data. And if you also expect actually the response time, you can see that this result was obtained by running the SpecWeb benchmark with around 5,000 users. And even if the number of users is constant over the time, you can see that there is a huge variability. It seems that the behavior of the VM hosting the application switches from fast to slow status, probably because of the contention of other VMs that were running with the hosted application. So, to have also some more evidence of, so these are the data we gather also for other pages. So you can see that this behavior under heavy load is for many pages of the spec web benchmark. This is the logout, so this is a light load page, and this is the only one that is not affected by this kind of behavior. Then we have also investigated which are the effect of the wide area network for cloud applications. So what we did, again, the spec web benchmark has a client, a backend system, and the web server, which is the system of the test. And actually we run the test under two different configurations. The previous result I'm showing you were taken by considering a single availability zone of Amazon. So we were using the Virginia location of the data center. Then we compared what happened if we take the client in the east region while the backend, the web server, are running in the west region. And so here we have the result for the single site that will run at 6 p.m. In US when the load is live there. And these are the response time here. The scale is the variability is very small. Here probably you can approach 0.5 seconds up to 0.68 seconds actually. So the response time are good. These also follow some theory. This shape is similar to some closed mode. And so the results are good, and the standard deviation also, the response time for different number of users, the standard deviation is pretty small. If we try to repeat this, almost at 6 p.m. US, while considering the remote location of the backend of the web system, these are the results. We can get the latency, and everything was fine. Again, the standard deviation was low. But if we do the same test at 10 a.m. in the US, this is what happened. For example, so you can see here that the latency of the one is 3 times what we have measured in the night, and for 2,400 users, actually the spec web client has some timeouts. So if the response time is not, so if a page is not downloaded with a limited threshold, the test fails. And so actually we repeated many times the test for 2,400 users, and we never got a result. So the test always failed because of network congestion. Then here I have some results that have been obtained by my colleague Giuliano Casali. And actually, so we saw here that there is a problem with the wide area network of Amazon, but we cannot investigate the problem in the wide area network. So Giuliano ran some tests with the FlexiScale infrastructure, and he was trying to measure the bandwidth between Imperial College and the FlexiScale data center located in Scotland. And here, I guess, the sampling is around 15 seconds. And here, you can see that there is a huge variability in the bandwidth available for the application. But the FlexN guys say, oh, but Jesus, this could not be a problem. Our bandwidth, our network is very big. We have a huge bandwidth. So we guess that this problem is really due because of the contention of the VM with the co-hosted applications. Because again, the current technology, if you consider the virtualization technology, you can reserve effectively the capacity of the CPU, but if we consider the I/O, we have more troubles, actually. So this is the kind of results that we got running real experiments. So what we do? Actually, our starting point is the Palladio component model. Again, we focus on the problem with design time. So the Palladio component model actually has been developed 10 years ago by Ralph Rosner and his team at KT Institute. And why they decided this? Because actually the Palladio model are some domain-specific modeling language that, however, are very close to the knowledge of the software engineer, and is able to separate. So is able to provide an ideal-level view of the system to the software engineer and map design-level models to underlying performance queuing network, layer queuing network, Markov chain, and so on and so forth. So we like this tool because it allows us to use the several engine for the performance and availability evaluation, for example. So this was our starting point, and before going ahead, I will just recall some concepts that have been used by Elisabetta yesterday in her talk. Then actually in MODAClouds, we are working with several layers of abstraction. The CIM we are considering component-based application, actually service-based application. Then we have the concept of a cloud platform, independent model, where the designer is considering some cloud concept like VM, application container, whatever, but the concepts there are independent of the specific cloud provider. While the cloud provider specific model, here we have a mapping to some resources that are provided by the cloud provider. And where is the quality of service evaluation performed? Actually, it is performed in MODACloud workflow after the functional specification of the application. So actually, here we have some preliminary phases that are performed by a feasibility study engineer that try to understand which are the best candidates for our solution, as also has been considered by Axel in the presentation yesterday. Then we have the functional design application, then we started with the quality of service assessment. And, okay, why? Okay. Up to the first slide, I'm sorry. Okay. I touched the wrong. Okay. So, after the functional specification of the application, we got some Palladio component model. This will be obtained through model-to-model transformation. We are working on this different project. So here I will show you just some models on the, again, the spec web benchmark. So this is the Palladio repository model where you specify the interfaces that are provided by the system and the components that will implement this functionality that are provided to the end user. Then you have the system model where you specify. So actually here we have a web server that provides the web page to the end user and the main queries that are performed on the database. Then you have the system model that shows that you have a web server component that is connected to the database actually. Then we have the resource model. Here the semantic that we use to the resource model is just placeholder for some resource container in the cloud. Then actually, what we did is we have extended the Palladio component model in a way that we can really evaluate the cost of use of the resources and the performance of cloud application. And actually the main limitation, so the Palladio is fine to model application at the CIM level, but there are some problems, some limitations for what concerns the CPIM and CPSM. So what we did is, and one other limitation is the cost modeling of the cloud resources, because Palladio is not the notion of cost, of time-varying cost of the resource, and neither the capacity of the system, because also the capacity of the cloud application will change with the time of the day, of course. Under heavy load, we can, the good point of the cloud is that you can allocate additional VMs to manage the peaks. And so this is the main point where we need to extend the Palladio component model. And so actually we are going to develop two tools, two